Hi guys, so in this video we're gonna go over section 9.2, which is motion on a curve. So this section we're gonna start off with acceleration and velocity. So we're given a vector function, so just like that, f of t I hat, g of t g hat, and h of t k hat, right? So how do we find the velocity of such vector function? So if you guys remember from your physics courses, how do we find the velocity of a displacement? So this is like a displacement because it's a position of a particle. So how do you find it? We simply take the derivative of a displacement, right, which gives us the velocity vector. So we're gonna do a similar thing here. So we're gonna take the derivative of the vector function in order to get the velocity function, which is going to be v of t. Okay, so we're just gonna take the derivative by component, like I told you in my video where I told you guys how to take the derivative of a vector function. So if you guys haven't watched that, I'm gonna post the link in the description below so you guys can watch that video. So here what do? We take the derivative component by component. So this is gonna be our velocity function. And then how do we find the acceleration? So how do we find the acceleration given the velocity? We take the derivative of the velocity, right? So we're gonna take the derivative of this velocity function, which will give us the acceleration, or we can simply take the second derivative of the position, which will give us the acceleration vector, right? So here we're gonna take the double derivative of this the I hat component, and then double derivative of the g hat component, and then double derivative of the k hat. So just remember, we take the derivative component by component, and that's it. What you have to know, that to find the velocity, just take the single derivative, and to find the acceleration, you do double derivative. And that's it. What you have to know for this part. So now let's do a problem. Okay, so here is a problem saying this is a vector function 2 cos t I hat plus 2 sin t j hat plus 3t. So this is a position vector of a particle. And what do we have to do? Find the velocity and acceleration vector at pi over 4. So what did I just explain to you guys? How do we find the velocity function? So we're given the position function, right? So how do we find the velocity vector? We will take the derivative of it, right? So you guys can do it all together, like writing the derivative component by component of like f, g, h, or you guys can split it out like f, g, h, and find it like separately and then combining it all together. I suggest doing this way, like when you have a short function like such, but when you have like a product rule and chain rule all together, then I guess this way it's better. So you guys can do whatever you want. Okay, so now let's get back to this problem. Okay, so now let's finding the derivative of this, which is actually the velocity function of it. So what's the derivative of 2 cos t? So the derivative of 2 cos t, so you have to remember what's the derivative of sine t? It's cos. Okay, sine x cos x. And what's the derivative of cos x? It's negative sine x. Okay, just remember that, and it's gonna be really easy for you guys. So now 2 cos t, it's gonna be negative 2. Derivative of cos, it's negative, so negative sine t I hat, and then this part where this is f, this is g, and this is h. Now we're differentiating the g component. Now this is 2, and what's the derivative of sine? It's simply cos, so 2 cos t j hat, and what's the derivative of t k? Like 3, so it's a constant, so this will just be 0, so we don't write it. Okay, so this is the velocity vector. Oops. So this is the velocity vector. Okay, now let's move on to acceleration vector. How do you find that? We take the double derivative of the displacement, or simply taking the single derivative of the velocity vector. Okay, now how do we differentiate this velocity vector? This is the f component and this is the g. So we will just do f prime plus g prime, right? Okay, messing up things. Okay, now minus 2. And what's the derivative of sine t? So you look at here, sine, it's cos, so just cos t I hat. And then what's the derivative of cos? It's negative sine, right? So you're going to put a negative in here. So negative 2 sine t g hat. And this is your acceleration function. Now you just have to evaluate them at pi over 4. So I'm just going to plug them in here. So in vt we're going to plug in pi over 4. So negative 2 sine of pi over 4 I hat, then plus 2 cos pi over 4 j hat. And if you plug this into your calculator, it should give you negative 2 I hat, square root of negative 2 I hat and plus 2 square root of 2 j hat. So this is the answer for part A. So let's just assume this is A and B. Okay, and now for acceleration we do, what is the function? So it's negative 2 cos pi over 4, plugging into this equation, right? Okay, now negative 2 sine pi over 4 and plugging into the calculator, and this gives negative square root of 2. Okay, negative square root of 2 I hat, and then this is negative as well, negative 2 square root of g hat. And this is it for part A. Now moving on to part 1, which asks us to find the speed of a particle. So how do we find the speed of a particle? So you guys have the velocity function, right? So here is your velocity function. So how do we find the speed of it? You will simply take the magnitude of the velocity function, which will give you the speed of it. So I'm just gonna write it at the bottom here. So what is our velocity function? So our velocity function is, let me scroll up, it is negative 2 sine t. Okay, negative 2 sine t I hat plus 2 cos t g hat. Let me verify I wrote it correctly. Yeah. Okay, now taking the magnitude of it, how do we take the magnitude? We square each component, then square root it. So now squaring each component gives us square it 2 cos t square and then square root it. And for this you have to remember a trig identity, which is simply sine square of x plus cos squared of x is equals to 1. Now applying this trig identity here, first of all we're just gonna remove these squares. So if we do square it, so it's gonna be 4 sine squared t plus 4 cos squared t. And now factoring the 4 gives us sine squared of t plus 4 cos, I'm writing 4 again. Wait, let's write it neatly. Okay, factoring the 4 gives us sine squared of t plus cos squared of t. Now we can use this trig identity over here. So applying the trig identity here, this gives us sine squared of t plus cos squared of t is equals to 1. So we're just left with 4, and which is square root of 4, and square root of 4 gives us 2. So this is the velocity, this is the speed of the particle. Okay, so we're done with part B as well. So that was it for this video. Thanks for watching. Bye.